So you can have your mic on, and then you can hear you. So I've been looking at the slides. All the chairs. I'm working. I think
that's on, but whether we need the mic in this.
It's fine, he's got it on the laptop. Yes.
You may have seen this already.
I'm just pleased that you're doing it, so thank you for taking the time.
It's quite all right.
Yeah, of course.
Hello, you're sorry for the slight delay. Can't not go.
Yeah.
Can't go.
Yeah.
So thank you for Tim to agreeing to give his practical insights talk. Without further ado.
Yep. Short and title. Still quite long. Need a better title. But morning. This is a bit of an insight into my professional life for the last year and a half. Been digging into the wonderful world of AI. So yeah. Hang on a second. Let's try that again. There we go. I didn't make these slides, so I've altered them. That's better. If you find me on GitHub and Stack Overflow, that's the face you'll find. The other one is on LinkedIn, the only publicly available picture of my face. And no one wants to look at my face all day. But I'm a principal technologist here at BJSS. I am a general tech enthusiast. I like playing with all things tech. And when I got the opportunity to start digging into AI, it was, brilliant. But one of the things, this talk is, it's a little technical, but I try and keep it at a relatively neutral level. But one of the things that I'm going to go into, and we've been sort of figuring out, is like how to apply it, but then how kind of when not to use it. Does that make sense? But this is all about how to use it because it's cool. Anyway, so before I go into like the case studies and the things that we did and the ways we applied it, let's go into a little bit about what AI is. And this has been around for a little while now, so people have probably seen a few versions of this, but so bear with me. So obviously, when we talk about AI now, we think ChatGPT and large language models and that generalistic AI. But AI has been going for a very long time, and it's coined in the mid-50s, and there were just this. Have to sit over there. No, that won't. Apparently, I can't click on it. Never mind. Anyway, so obviously it's been going for a while. There's a few things in history that stick in my mind from when I was younger. So I remember Deep Blue, and I don't know if anyone in the room can remember when Deep Blue beat Kasparov. It was huge. But it wasn't really AI as we know it now. It was just a supercomputer that could think faster than Kasparov. It brute forced him, ultimately. It could think further into the future than he could, more computations than he could, and just sort of, ground him down, I guess. Other than cats on YouTube and face recognition and stuff, the next kind of big one that sticks in my mind is 2016 when AlphaGo beat Lee Sedol. Now, that's different to Deep Blue because Go is a different game, obviously, but you can't brute force Go in the same way that you can with chess. I'm not a Go player, I'm not that bright, but the AI had to be creative in its solution to beat him, which is significant. And then 2020, GPT-3 arrives, and everyone in the world now talks about AI and what it can do. And then in the last few years, it's kind of boomed. I think I remember reading. So we've got this. I'll go over this in a second, but we've got this 2029. This artificial general intelligence, right? This. I always have this. I always have Morpheus in my mind who goes, "We gave birth to AI," and it's like this is the thing. It's like, I think it was coined it for 2060, but due to the rapid evolution of large language models, they've kind of predicted and brought it a few years forward. But in what was it 2023, GPT-3 launches, and within 2 months there were 100 million users. Massive growth. And then we've got Bard and Claude, Google come on board, Claude come on board, Gemini is there. And then you've kind of got earlier this year, you got these multimodal models. Now everyone's got multimodal. I played with the latest version of Gemini recently. Okay, quick question: who hasn't used ChatGPT? When I've done this before, I've had a couple of hands, but it's always not very many. Who understands what the idea of tokens are when it comes to language? Oh, who tokens are? Okay. Okay, cool. So when I talk about tokens for large language models, I talk about a context window. That's ultimately how much data you can send to a language model. So, as you can imagine, like when I went to uni in the early noughties, it was the internet was slow. It can only transmit a little bit of data. And now you've got a 1 gigabit fiber line coming into your house, and it's the same sort of thing. It's like when GPT started, the amount of data that you could send to the language model, the amount of data that it could consume was 4,000 tokens. That's roughly 4,000 words of text. Gemini now can take in 2 million tokens. That in a year is huge expansion. There's a think tank going on with something called LongNet. I haven't actually looked into it recently, where it's got to, but LongNet can look at 1 billion tokens. And the way that they put that into kind of reality is like an average human can read or will read around about 60 billion tokens of text in their lifetime. So, imagine it's a 1 year's worth of reading you can send to this language model for instant kind of consumption. So, but I play with Gemini. Gemini is 2 million tokens, which is huge. I mean, it's a multimodal model. We went down to the XR Center. We were there with Google and Formulary, and we were playing around with track data, and we could send it a video of an entire Formulary race, and it would then consume that and then tell me about what happened on that race. And we could also then send like different camera footage, and we could get it to tell us where the events were. It's just mind blowing. So yeah, where the game go to next is a bit crazy. Anyway, so basically what we've talked about there is the idea of narrow AI, which is Deep Blue and Gemini, and an AI that's designed to do a task, and then general AI, which is what we all know and love now as GPT. Incidentally, as a dyslexic, language models have changed my life. I don't have to think about writing anymore. It's fantastic. So AI is good for like automating tasks and finding patterns, and actually now it's pretty good at augmenting humans. And I'm going to go into a couple of these use cases in a minute, but we've found that it's really good for like things like developer experience. I don't know if anyone used GitHub Copilot in the room. I both love and hate it. It's really good sometimes, but awful at others. It's about understanding how to control it from going a bit haywire. Employee experience is really good. Enterprise search, we've done that a lot. Knowledge management, one of my case studies is all about that, and obviously conversational AI. But it can't be an AI talk about without going into detail about a couple of examples of where AI can go wrong. Has anyone heard about DPD? So what happened with DPD? So DPD put a language model on their website as their chatbot, and they didn't put any safeguards in. They just put a chatbot on the website and linked to a language model, and then people jailbroke it. They got it to sing songs about how terrible DPD were, write poems about how absolutely awful their delivery service was. This obviously hit the news and was embarrassing. But then Canadian Airways, that example, where they did the same thing. They put a chatbot on their website. It had access to all their user material, all their customer material, and customer had asked it if they could refund their ticket for whatever reason after their flight. Now the language model went, that seems like a reasonable thing they can do. Yes, they definitely can do that. I mean, it was logical. The question, yes, it was, the actual procedure was refund, get money for it before the flight, not after the flight, but it doesn't matter. The language model just assumed, based on the information it had, that it would be feasible. So that's what the customer did. And then Canadian Airways said, no, you can't do that. But your website told me. So they went to court, and their lawyers tried to their defense was that the language model was basically its own person. They didn't have control of what it was saying, and they go not these words, but basically go sue the language model, please. And obviously that got thrown away because it's utter nonsense. But it just shows that and as we'll go into in a little bit, building stuff with AI is really easy and really quick, but getting it in front of customers and productionizing it takes time and effort and is potentially problematic. Right. So our journey. So these are a few examples of how we applied AI, and for us, it started with a question. So the question basically was, we've got some really awesome content over here, but when we write new stuff, we always write it from scratch. That seems a bit inefficient, doesn't it? And even if you know our code base, or not our knowledge base, and you're writing all these new articles and proposals and things like that, you still have to know where to look. So can we use AI to generate new content? Can we use AI not to just generate new content, but to use our well-written, reviewed and signed off data to generate new content? Like, cool, I'll do that. Sounds fun. So the question was, I want my user prompt. This is what I want, and I'm using this as an example, because the example I use for vectors tickled me. So here we are. So we want to write an article about how to barbecue a chicken, because everyone loves chicken, apart from my wife, apparently. And then the AI response is like, yes, certainly here's an article, and I base it on all the info, all the wonderful content that you have around barbecuing chickens. So we need something in the middle to go off and get that data and do some crazy stuff. Who's heard of RAG? With regards to AI anyway, because RAG is red, amber, green, and that kind of stuff. But so RAG stands for retrieval augmented generation, and the idea is that you have something that retrieves some data, you augment your prompt, and then you generate your response. Because a lot of people I speak to, when they talk about how to use AI and how to prompt and how to kind of curate the prompt, well, okay, well, I asked it to do this thing, but didn't really do what I wanted it to. And I thought, did you tell it? No. Or how does it know what you want it to do without being extremely prescriptive in your request? So we thought, well, that could work, and then we need to orchestrate it in some manner. So retrieval, what we did was we looked into the idea of a vector database. So a vector, without going too deep into it, because it's a little beyond me. This is data science world, and I'm just an architect. I know little bits about lots of stuff, but not lots of stuff about the whole thing. Is it turns text into matrices, into numbers that a computer can understand. And so what we did, you've got a source material, and that goes into our vector database. So this is obviously simplified to absurdity. So we've got our, barbecue for beginners, we've got cooking over here, we've got some text in number form over here, we've got hygiene and building a barbecue, and then we've got kitchen nightmares because it's cooking, we've got profanity over there, and some hygiene stuff over there, and cooking. And then we've got, we've got some stuff on farm welfare because, it's got chickens in it, birds there, blah, blah, blah. So it's split up this document and put it into this sort of, the way I picture it is this like three-dimensional space where you've got lines, like three-dimensional lines on a graph. And then when you ask the question, this, it does a deep vector search, does a nearest neighbor thing, which you could Google and go into more detail. I won't expect me to explain it right now, but because I probably couldn't. But basically, when you ask the question, it goes, this is where that data is. So it returns chunks of data or chunks of text from that area that are closest to the question that you're answering. We then take those snippets of data and we build a prompt around it. That prompt is, here's my question. Only answer given the data you're provided. Here's the data. Only answer given the data you provide. And by the way, please only answer given the data you've been provided. Genuinely, I think it's called prompt whispering. You just repeat yourself over and over again, and it finally does what you ask it to do. And then we send that to GPT-4, and we get a nice response. And then we wrap it into a nice custom app, and you've got a nice little front end, and yeah, that worked really well. We built that in about 2 days, roughly, throwing together examples that Microsoft put on there and hacking together Python code, generally hacking because I'm a .NET engineer, and kind of proved its worth. And then we worked for months to make it good and usable and nice and not break every 5 seconds. But now we're here. We have a nice app that you ask it a question and it looks into our knowledge database and responds accordingly. And genuinely, it has saved people a lot of time. It's not weirdly, because anyone who's been in the software industry understands that when you have an idea, when you build a thing, it's never used how you want it to be used. It's used in a different way. But in this particular scenario, that is the case. But the way it's now being used, it's a glorified search, but it's become very popular, and people will be upset if it went away, which is always a nice, I did all right, thanks. So it's ultimately democratized our knowledge base, so that the people who know the stuff, like the handful of people that know the stuff, can go, well, just go use this app. You can do your own research, and it frees up their time, and we, it's really good. So this idea of RAG, where you've got a set of data that you want to answer questions on. Why do I do this over just using ChatGPT? Well, the idea is if anyone who's used MS365 Copilot, which you can install in your own organization and point at a SharePoint, it's great. But if you wanted to ask a specific question about a specific set of knowledge, it can go a bit off piece. And obviously, if using public ChatGPT, I mean, I always say to people, it's like, if you won't post it on Stack Overflow, don't put it into ChatGPT, because that's, who knows what they're doing with it. They don't really tell us. And so the idea is if I want my answer to be based on a specific subset of data, this is how you do it, and it works pretty well. So one of the examples, so we built this app, it's really cool, and we've got all the code so we took this code and we deployed it for a customer who have a set of medical journals, hundreds and hundreds of them, written in a way that I certainly don't understand. But what we did is we just did the same thing. We indexed and vectorized all that data, put the app around it, and now what you can do is you can ask a question like, what about your SARS research, and then can you please dumb that down, please? So if I'm a 5-year-old, I can understand what you're saying, and it works really, really, really well. It takes that complicated technical jargon and turns it into something that everybody can understand. So democratizing that knowledge. Another example of what we did with this is we have a team doing very much it's a user research team. We've spent years building up user research documents, Miro boards, PDF documents, Word documents, PowerPoints, whatever, gathering information about how to best build an app. And they have people onboarding and offboarding all the time. And what they found is the onboard process is really slow. It takes a lot of time from the people on the team already. And a lot of them are the same questions. But those questions kind of change as that documentation and as the project moves on. So we did the same thing. We vectorized all the data. You can vectorize images, as long as you've got text in it, of course. And we had screenshots of Miro boards and this, that, and the other. And then anyone who are on board into the project now go, what about this? And they can dig into that information and start asking the questions they want to ask. And then once they've got a decent grounding in the subject, they can then reach out to their colleagues and spend a bit more time with pointed questions, right? Cool. So RAG, that's really cool. Worked really well. So it's this intelligent AI search, and so we use AI search. We grounded our prompt in the text that that we want the language model to respond to, and we find it like I said, it democratizes that knowledge. It reduces that barrier to entry for people onboarding or wanting to find something, and it actually saves people a lot of time. Cool. The next thing, so we did this and everyone was really happy with it. So then I got lots of people going, well, could you do this? I was like, okay, sounds good. I'll keep digging into AI. So the next question was, so as a consultancy, everything we do, we have to bid for. And everything we do, we have to have some sort of conversation with somebody else who's paying us to do that stuff, because we're obviously not a product house. And we're lucky in the fact that the people who the clients who we put out these proposals to will send us their thoughts. If whether we win or lose, they'll send us some feedback, which is really useful to us. I mean, whether it's whatever job you're in, having that cycle of feedback is really useful. But we get these feedback from a letter that says, yeah, your call did really well, to we didn't let you go away, to 10 pages of detailed feedback on why we did or didn't do well on a particular question. And I was asked, so how can we improve the beginning of our process by consuming that feedback? And there are many manual processes in the way you do that. But what we wanted to do was try and build some kind of dashboard that had that insight from that feedback that you could go into and see, oh, this is where we're not doing so well. These are the trends over the last year or so. And we tried some traditional sort of machine learning methods, which we didn't try too long, to be fair, but we tried to use typical text extraction techniques from documents, but the problem is that we don't control the clients and how they feedback the document, they send it in whatever form they like. And we've basically found the data was too unstructured for that. So what we did is thought, well, we'll see if we can do it with a large language model, because in theory, it doesn't matter about the format. It's just text that it can understand. So what we did is we've got this. So again, we've got a source material, we extract the text through some fancy means, but then we've got this idea of a multi-step, multi-prompt approach, which I'll go over what one of the prompts in a second. And say the prompt, we tried one really long prompt that did lots of work about understanding sentiment and trend and pulling out summaries and scores and this, that, and the other, but it wasn't very accurate. So the idea is that you actually break that down into smaller tasks. And those tasks are still quite big, as you'll see in a second, but you try not to get the language model to do too much at once because it kind of gets a bit lost. So here's one of our prompts. And the reason why I'm showing this, I don't expect you to read it all, I'll go over bits in a second, is that when I show this to people, they go, I didn't realize you could actually tell it how to output it. Oh, that's a lot of text. I'm normally just, a one sentence question. So we give it context. We tell it that the text is wrapped in particular braces, and we give it an idea of what that content is going to contain. Because from my understanding, if you give the language model a scenario, it can look in its training data to find similar scenarios that it can use as the grounding to then continue. We tell it what it's going to be doing. We tell it how to extract that data and what we want it to do. We give it the output format. We then tell it not to wrap it in Markdown and tell it not to wrap it in Markdown again. And every now and again, it still wraps it in Markdown, so I have to write code to strip out the Markdown. It was almost, without this line here, it was wrapping in Markdown almost every time, despite you telling it not to. And with that line in there, it only happens once or twice. But it still happens.
Unintentional spelling mistake, not an option. I wasn't clear about this intentional final sentence.
No, that's just the dyslexic writing a prompt. Yeah, it's brilliant. Part of it. We then give it a step-by-step task to do. So we tell it how to approach that task. And actually, since this, I did this talk a few weeks ago, and in the room were a few data scientists, and I always struggle with this because I've got a lot of experience into this, but there are people who know this far better than I. And she's like, oh, that's quite interesting. What we've found is that if you tell it to take a break in the middle, it actually works better. So like, there'll be an in-step in the middle there, go, right, stop for a minute, think about what you've done, then continue. And so, oh, all right. And so I've tried doing that, and I don't know whether I'm getting better results, but it's working. So yeah, that's just one prompt. We have many of these prompts and sometimes the output from one prompt we feed into another, so that we get it to extract some data, and then we get it to kind of categorize and summarize that data, to try and so it doesn't have to do it in one go. So yeah. So we're not using, there's no actual user interface in front of this language model. This is now part of a data pipeline. So we also applied this to a local company, actually, that we looked at doing the same thing in the complaints process. So obviously we weren't, well, I think it's Airbnb. I'm not sure if I'm remembering this correctly. Have actually got AI in there in their customer service process, and they've seen a massive improvement in customer satisfaction because they are responding to quicker. But this particular scenario was you have complaints that come in through different multiple different streams, like telephone calls, you've got transcripts and forms and emails. And then the complaints handler needs to consume that information, categorize it, fill out forms to put data over here. So we kind of did all that automatically. We took that data, we stripped out stripped out all the content, called an API to fill out a form. Actually, here we are. And also like, generated an example email that is tailored to that customer. But the complaints process, the complaints handler still steps in to do the human interaction, and it saves them time. So they don't necessarily get through cases quicker, but they can spend much more time with the customer to make sure they are, that customer satisfaction is better. But we did this very quickly. We didn't put a language model in front of customers. So we always have a human in the loop to make sure it's correct, and that worked pretty well. So again, this is my kind of second example of extracting data from unstructured sources. Because the beauty of this is if I get a new data source in a different structure, a different file format, it doesn't matter because this will just handle it. Because ultimately, I'm just pulling out the text and throwing it at a language model. But I got, I think it was DALL-E, to to generate an image based on the Think Byte campaign, but Think AI, and this is what I came up with. Kind of liked it. So it's just we can't wait to talk about AI without talking about ethics. We need to think about what we're doing with it. The idea that roles. I think it's hitting the IT industry, particularly from engineers. But it's going to change, and we need to make sure that it's going to change the industry. We need to make sure that we're bringing people along with it. The first example that I showed way back when about the resource org is about generating content. We've got a team that does that, and we need to be mindful that we're not going. And by the way, you don't need to do your work anymore if you've got an AI to do it for you. This is here to help you, so you don't have to do the menial stuff. You can do the stuff that really impacts the company, and you can get AI to help you do the stuff that's just really dull. And always be transparent and that kind of thing. So always kind of think about it. And also when you think about should I use AI, think about sustainability. Because obviously it may not be obviously, but it uses a lot of energy, a lot of electricity, and a lot of I can't work because I think Jonathan, you found every prompt was like a bottle of water used or something. So it's just use it sensibly, and when it's used in the right way, you can reduce the amount of time that you spend doing a thing. So you're not spending the energy and electricity for months of work, and you do that in a couple of days. So you can kind of but at the same time, I think we did a workshop with an educational institution, and they basically just wanted data validation. So we don't need AI to do that. You can do that under the means, and probably cheaper and quicker and easier. They just wanted to use AI because AI was cool. So yeah, in summary, we need to we obviously need to think about when we use it. It's going to be it is a game changer. It has changed the industry. We've seen that it's going to continue to do that in my opinion. But organizations need to embrace AI. I remember having a conversation, it was last year actually, with another potential client. He was asking, should we do AI? Is it ready yet? And I said, well, at the time, my answer was no, it's not ready yet. But if you don't start looking at it now and understanding how you can use it in your business, your competitors will be, And then by the time it is ready, they're going to be 6 months or a year ahead of you. So start looking at it now to understand how you can apply it into your business so that when it is ready to do so, you know what you're doing. And then to kind of loop back to the main title of this, how did I start? I started with a single idea. So if I'm, again, having focused use cases, if it's just general, just use ChatGPT or MS365 Copilot. Why spend the time building something? But if you've got a focused, specific use case that will you can apply it to, that's really good. Rapid prototyping, because we did it in a couple of days, and then I put it in front of people who kind of go yes, sign off the checks and that kind of thing. Oh, this is really cool. Please continue. But if it can seem like a lot of vaporware to talk about AI, but if you put something practical in front of somebody, like anything really, but AI in particular, it can really build that engagement. Oh, this is really cool. This is really interesting. Please continue. And someone asked me, it's like, where do you get 90% from? I made it up. But it's because I found roughly it is around about 89% accurate. It's not right all the time. So if you're happy for it not to be right all the time, but to be right the majority of the time and save you time, then it's really, really useful. Okay, that's me. Thank you very much. But how long have I been? Prompt engineering. But prompt engineering, one of our Sheffield colleagues hates the term prompt engineering because it's not real engineering. And I was like, well, I don't necessarily. He's a data scientist rebranded as AI specialist, and I don't necessarily agree with that. I think it is engineering. You have to understand how to get out of it, but it's not like learning how to write JavaScript or C#. There aren't set rules. It's kind of just figure it out as you go and see what works. And you have to do something, I've been working with one of our AI specialists recently to improve our RAG app. And we've been looking at our chunking strategy. So that's the vector database, the size of the bits of data in that vector database. How big should they be? And something I didn't think of at the time. So, well, actually, what you can do is you have a 500-word chunk, but then you have overlap. So you've got a 100-word overlap between these chunks, so that when you're searching for data, it has context, so it knows where it came from, knows where it's going to. Also, the idea of semantic chunking, where you actually use a language model to send the data to chunk it up, and then you put this into graphs and metrics to actually find out what gave the best results based on a base data set. And interestingly, I thought semantic searching would really come out on top. It doesn't. Just a 500-word chunk with a 100-word overlap actually performed just as well, and is much cheaper to do, which is not what I thought it would. That wasn't my expectation, but based on that data set, that's what I found. So I kind of went off on a bit of a tangent there, but prompt engineering is.
There's different types of AI out there.
Oh.
Could you do the same case study with all of them and get the same results?
When you say different types of AI, different language models, so different types of yeah, exactly. I mean, we use GPT-4 because we've got good sponsorship from Microsoft, so it was cheaper. And we also got early access to models in Azure, so we can now play with O1 preview as well. But you get the same thing from Gemini or Claude. Yeah.
While ago, I'm curious to see how other people approached it, but did you ever have to apply access rights to the documents in your search?
Yes, I've kind of done it in a weird way, is that it's all linked to SharePoint, because all our data is in SharePoint, and it's all done done through SharePoint access. So when you log into the app, it actually looks to see whether you've got access to SharePoint before it allows you in. So that the people who control access to that just have to access SharePoint. It's a little janky, but it does work. It does work. Yes, you can federate stuff from Microsoft to Google, can't you? But
and yeah, it ended up not going ahead in the end because 4 petabytes of Google Drive data in Azure Cognitive Search was expensive.
yes, yeah, that sounds expensive.
It's a good one. If you have a client with a question, a need, but they want to say, we want it to be 5% accuracy in terms of like the output. Is there a way of, being able to provide, oh yeah, okay, it's going to be accurate to within 90%, or is it just between 80 and 90? Always, I know, I guess it depends on the content, but is there any way of being like, okay, based on all these thousands of responses and analyze?
Based on my knowledge and my experience, and this is obviously isn't it's not a great sample pool, but time and effort, and it's very much trial and error. And so I don't know is the answer to that. We're kind of working through that at the moment by improving little bits of the different bits of the app, like the improving the prompt, changing the language models, breaking the prompts up, improving our chunking strategy. But even then, we had a case. I don't want to say hallucination, because that seems to be like a dirty word now when it comes to LLMs. But it's more it misconstrued the, if that's the right word, the text that we provided it. And if someone who'd been here for a while read it, they'd understand it. But one paragraph kind of inferred in one paragraph it kind of inferred that it did something with the previous paragraph, where actually they were very separate. And if I think it was written in such a way to kind of put in a little bit of so you did it didn't directly specify, but you could have gone, well, actually, yeah, that thing used that thing, and it just assumed, well, yeah, okay, of course it did, because you talk about this thing over here, and then you talk about another thing over here, and this obviously used that thing over there. And there's no way of, because it didn't have the greater context. So there's always going to be, at the moment at least, there's always going to be issues, and it's all about the time you put into it as well, because obviously you don't want somebody, if you had a group of people looking at their source data and reading through and manually chunk it up into bits that were that were correct, then maybe it'll be more accurate. But yeah, time and effort, I think, is the answer to that one.
Just on that as well, I've been looking into a lot of this myself too, and there is tuning that can be done at the vector search stage. So when you're searching in your source book, you set out algorithms you can use to take the time to get more relevant results. But then when you throw it into the prompt, it's less controlled.
Yes, yeah, because you've got your retrieval, which you can improve, but what the language model decides to do with it is anybody's business.
Yeah, that's you said you did like one set of prompts, and it's found out the answer that you want, but don't see them whole plants, right? What made it wrong? How do you know?
Because I looked at the results and then read the original data. But basically.
So is that not introducing quite biased, right? Yeah. I can't, that's supposed to do it.
Well, no, because this was pulling out numbers. So the document said, you know, this number, and the language model brought out another number, which it found else somewhere in the document. But so you know, it was quantifiably. You can test it in the sense that I expect these numbers to be the numbers I got out the other end, and it didn't produce them.
So that leads me on to the question I was going to ask, which is my very high level understanding of all of this is that at least with machine learning, you've got that sort of almost validation data set of what you expect the training data to produce as an okay model. Have you found that it's only human validation that you've employed to actually work out, or is there other ways that you?
The only real way, because because if you're generating, so it depends what you're doing. If you're extracting data from a document, you can verify that data is what you expect it to be. But if you're generating text from some other text, that text is always going to be different. So the way that we've done it is to use the language model to then verify that that response is accurate. And then and you can do that, and we're looking to build that into our RAG app as well. The idea of AI agents is a whole new thing about autonomous language models doing what they think is best, and bringing agents into the idea of RAG so that when it gets its response, it actually checks itself and fact checks itself based on additional data. So it can go, well, actually, my response isn't that accurate, so I'm going to go off and try again. But yeah, language models to test language models. It's like who watches The Watchmen? No worries.